Okay, so this is a projectiles question, which means like all projectiles questions, we need to remember that the only force acting is gravity, and that's always going to be acting in the vertical plane. Tennis player serves a ball from a height of 2.51 meters with an initial horizontal velocity of 18 meters per second. So I'm just going to pop that in there, 18 meters per second. It just clears the net, which is 1 meter high. First question is asking you to calculate how long it's going to take to reach the net. So looking at our diagram here, if it's reaching the net, then it is falling a distance of 2.51 minus 1 meter, the height of the net, which is 1.51 meters. So that becomes our vertical distance. We know we're modelling this in the vertical plane, so we write our SUVAT down. S is 1.51. Initial vertical velocity there is 0. We don't know our final. We know that our acceleration is 9.8 and t is what we are looking for. So we want to find the SUVAT equation that includes S, U, A and T, or some combination of those. Well, the easiest one to use is S is equal to UT plus a half AT squared. Rearrange this to find T. Well, our UT is going to disappear because our U is 0. So T is going to be equal to the square root of 2s over a. Then we just plug our numbers in. 2 times 1.51 over 9.8, all square rooted. That gives us an answer of 0.56 seconds, which is approximately 0.6. So don't forget, when you're being asked to show that it takes approximately that much, always have your little summary saying, look, my answer is nearly what you're looking for. Part B is asking us to calculate the vertical component of the velocity as it passes over the net. So again, in the vertical plane, what do we know? Well, we know that our acceleration due to gravity is 9.8. We know that the initial vertical velocity, u, would be 0. And we know the time it takes to hit the net. We calculated that in the previous question. So again, we write down our SUVATs and we see what we have. It's travelling a distance of 1.51 meters. That's taking it from its start point to the net. Our u was 0. Our v, we still don't know. That's what we're trying to find. Our a is 9.8. And this time we now have the t as well. That's our 0.56 that we calculated in the previous question. So again, we just find the best SUVAT equation to use in this one here. We want v, and we have everything else. So we're going to use v squared is equal to u squared plus 2as. That's going to disappear down to 0 again because our u is 0. So v squared is just equal to as. This means that v is equal to the root of 2as, which is equal to the square root of 2 times 9.8 times 1.51. And when we plug that in, we get an answer of 5.44 meters per second. Then the final one is asking us to calculate the overall velocity. Now that means as it goes over the net here, its velocity is going to be in that direction there. We'll call that VO for V overall. Now that's going to be made up of its horizontal and vertical components, VH and VV. VV we worked out already, it's 5.44, and VH we are told in the question is 18 meters per second. So what we're trying to do is work out this resultant here. So we can draw our little triangle. It's got a horizontal component of 18. It has a vertical component of 5.44. We're trying to find the overall resultant here and the angle to the horizontal. So the angle theta that it makes to the horizontal there. And so we can just use Pythagoras to work out the resultant. Resultant squared is equal to 18 squared plus 5.44 squared. So my resultant is going to be equal to the square root of all of that. And that gives us a velocity of 18.8. And we check, does that make sense? This is the hypotenuse. I'm expecting it to be a bigger answer than either of my horizontal or vertical components. So there's my answer for the velocity. Now I need to work out this angle here. And I want to use at least the value that's given in the question, because that's the one that there is less ambiguity about, because I haven't calculated that. So for this one here, because when I worked out my hypotenuse, that was being worked out using an already calculated value, it's less imprecise to use my opposite and my adjacent. So using SOHCAHTOA, I know that tan is opposite over adjacent. So tan of theta is 5.44 over 18. So tan to the minus 1 of theta on your calculator is equal to 5.44 over 18. Therefore, theta, when we type this into our calculator, comes out at 16.8 degrees. And there we go.